Hi everyone, my name is Jorge Panuco and today I'm going to talk about the automation of this project. This project is a reactor automation for chemical products. So let's go ahead and see what we have for today. As you can see, I have six mainly points: the controller, the sensors and actuators. I'm going to talk about all the process that this project has, also the variables that we'll be measuring, the degree of automation, and all the signal acquisition that we're going to be having. As you can see, our controller is going to be Arduino Mega. Why? Well, because it's an open source platform based on easy to study and use hardware and software. This programming environment is very simple and direct. Even a child from secondary or a teenager from high school can use it. This controller senses the environment and affects its surroundings by a lot of sensors like ultrasonics, infrareds, temperature, or even wind sensors. You can tell you are doing what to do by its code. It's a very intuitive interface, and you can use it since its libraries and all its language is very easy to use. As you can see, I have five main points for this controller. Its economy, it's very affordable. Why? Because all these costs vary between 300 pesos to 1,000 pesos, so it's not that expensive as another controllers. Also, it's a multi-platform. It's very reachable. You can use it in Linux and Android or iOS, Mac, Windows. So there's no excuse for not to use it. Its programming, as I told you before, is very intuitive. This language is very easy to use, so we won't have to struggle a lot in this project. Uh, it has like a lot of inputs. Most specific, it has 54 inputs, which 14 of them can be used as PWM outputs, and 16 analogs inputs has also USB connection, power jack, um, ECSP connectors, and a reset button. And all its outputs are very multifunctional because you can connect motors, you can connect a LCDs, you can connect matricial keyboards. It's very useful, this Arduino Mega, so it's going to be our controller for for our project. Okay, now I want to talk about oral controllers and our sensors. The first one, we have solenoid bulbs. A solenoid bulb is a electromechanical bulb controlled by passage through a fluid, by a conductor or a pipe. Usually it has no more than two positions, open and closed. So it's going to be very useful for our project. Um, it has a 12 voltage of current of direct current, uses zero point 0.6 milliamperes, and it costs is of 463 Mexican pesos. Okay, then we have a relays. It works as like a switch controlled by an electrical circuit. It allows all our circuits to work and not to have a malfunction. And specifically, and the relay that we are going to be using is a 8 relay one module with 5 voltage of direct current, 10 amperes, and a cost of 835 pesos. Okay, these two came as a package. Why? Well, because we have by one side the matrix keyboard that it will allow us to select the amount of raw material that we want to use. Yeah, by typing the number one, two, or three, we're going to be selecting the amount that we want to use. It's a rigid matrix type and with a cost of 810 pesos. And then we have the LCD. This LCD is going to be showing us the previously number that we just choose of material. Its specifications are 80 per 10 per 35 millimeters. It has 32 digits that comes from all the alphabet to these to all the letters that we use in our daily life. Its background is blue, but it also can be green, and it has a cost of 87 pesos. Then we have our load cells that are very important to us. These load cells are going to be our sensors that measures the weight of the raw material that is going to be in the tank. Um, these are going to be connected to our controller, to the Arduino, because it has a serial digital output interface with a voltage of direct current from 3 to 12 voltage. Um, its maximum amount of weight that it can charge is 10 kilograms, and its cost is from 200 pesos. Then we have our power source that is going to be feeding all of our project with electrical power. It works with 12 voltage of direct current, and it has a cost of 257 pesos. And to finish, we have the summing box that is way too important in in our project. This is used for add or unify forces when there are different scalar measurement points. For example, we're going to be using this one for the load and the sensors. This allows to increase the maximum weight or force to be measured since the loads of each sensor are added. It's accurate better than 0.1 fs. Its measures are 9 per 5.2 per 2.5 centimeters. It works with 12 to 24 current voltage. It also works with from 4 to 20 milliamperes with an output signal, and it costs 620 pesos. Okay, so now I want to talk about or tell you about the whole process that is going to be involved in our project. Okay, so imagine a, a project that a tank, a lot of tanks. Each container will be containing it will be assigned a letter. For example, A, B, and C. And by any means of the matrix keyboard, the desired quantity in kilograms of each example container will be selected. For example, you're going to be typing in the matrix keyboard, for example, 13A, 4B, 56. This means that you want 13 kilograms from the container marked as A, 4 kilograms from the container marked as B, and 5 kilograms of the container marked as C. All these will be dispensed to the reactor, where this will be mixed with the help of a small motor to achieve a homogeneous mixture. These signals of the keyboard is going to be first of all introduced in the Arduino. Then the signals processed by the Arduino and all this programming are going to be working with the solenoid valves that are going to be allowed to let the liquid go out. And then when the liquids goes out, if you want to, you can add like a glass or something to don't let it spill it. The loading charges are going to be measuring the weight of the raw amount. So when we select 13 kilograms of A, it's going to be very specific. If there are, we this won't give us like 30.1 or 12.9. No, it will give us 13 kilograms exactly. Okay. Okay. So then, okay. I'm going to talk about all the signals or all the variables that are we going to be measuring. Obviously, we have to measure all the signals of the inputs that we're going to be using with Arduino. For example, when we are typing the amount of substance that we want in the matricial uh, keyboard, we have to measure and verify that all the signals are given correctly. Because we don't want to have something wrong and then to have um, to export something or to have something wrong. Okay. Then the next one that we want to be measuring is the weight. Why? Because the weight of the raw material is very important on this project. Usually, mainly the load cells and through the summing box that we will be receiving the values. It will be detecting and measuring the weight of the raw material that will be used. Because as I said before, when you select the right amount of the raw material, these variables needs to be very specific, so this won't be any failure in our project. Okay, now I'm going to talk about our degree of automatization. This project is going to be mainly and only mainly focused on the chemical products. Why? Because due to the type of the materials, obviously, we can mix the food with chemicals, or I don't know, the something that you can mix like alcohol or milk, water. We can mix it with chemicals because it won't be safe. Um, it can be adapted as their needs, but in this automation, the product dispense of the reactor, it won't be packing either. So it will be a rigid degree of automation. If we want to use it as for food or something like that, it will be flexible. But as we won't be using it as it's rigid. And to finish, I want to talk about our signal acquisition. Mainly, we're going to be using Arduino as our signal acquisition because all the signals that we will be receiving, the Arduino is going to be working with them and converting them into actions. Whether it's a signal emitted by the summing box or by the solenoid bulbs, the motor, the relays, or by mainly by the matrix keyboard, this will be converted and analyzed so previously by the previously programmed actions carried out. And also another one that is very important is the summing box. These values emitted by by the load cells will be analyzed and converted by the sum box into signals. As I told you before, the amount of raw material that is in these tanks will be created by telling for the load cells emit the signals that we'll be receiving by the sum box, and thus to be able to use exact values that will be used. If we don't have a good signal acquisition by the summing box and by the Arduino, this project won't will work. So we will be struggling with it in the future. And that's it for today. Thank you for watching. If you have any doubt, you can tell us next week. We will be thankful for receiving your attention. And that's it. Thank you.